Hello, welcome back once again. Today we have a definite integral, right? And this is from G advanced integration. So here we're going to find the integral of sine of x divided by 2 plus tangent squared of x dx with a limit running from 0 to pi all over 2. First, let's call this integral I. Then our I is going to be equal to the integral from 0 to pi over 2. Then this is sine of x divided by, so we have here 2 plus, then we know that the tangent squared of theta is the same as, tangent squared of x, is the same as the sine squared of x, then divided by the cosine squared of x, according to the trigonometric identities, okay? So this is going to be equal to the integral from 0 to pi over 2. So we're going to multiply the numerator and the denominator by the cosine squared of x so that we can see the outcome. Okay, so is that what we're going to do? Let's check it out. So here we're going to have the sine of x, then multiply by the cosine squared of x. Get idea? Then divided by, so we're going to multiply the numerator, the denominator as well as by the cosine squared of x. And here we have 2 plus the sine squared of x, then divided by the cosine squared of x. And then we have our dx. So take a look. At the denominator, we have some nice cancellations, right? So our I is going to be equal to the integral from 0 to pi over 2. So up there, we just have the sine of x, cosine squared of x, then divided by, so here, cosine squared of x times 2 is giving us 2 cosine squared of x, and then plus. So if you multiply the cosine squared of x and the cosine squared of x get cancelled, and we're left with sine squared of x and then dx. Then here comes the magic. We have the integral from 0 to pi over 2. Up here we have the sine of x multiplied by the cosine squared of x. So down here we're going to do the following. 2 cosine squared of x is same as cosine squared of x plus cosine squared of x, and then plus sine squared of x. Don't forget our dx. Then take a look. This is equal to 1, right? Oh my god, that's cool. So here we have I is equal to the integral from 0 to pi by 2. So we have sine of x, cosine squared of x, then divided down there we just have 1 plus the cosine squared of x, and then we have our dx. So it is easy enough to make a substitution, right? So we're going to make a very nice substitution from here. And what's that? So we're going to let t equals the cosine of x, and we know the t is going to give us the sine of x dx, and we're very lucky, right? Is that going to, the negative sine of x dx, which also implies that negative dt is going to be equal to sine of x dx, and we're lucky that we have sine of x and we have dx, right? So making the substitution now, our I in terms of t is going to be the integral we forgot about the limit, right? So if x is approaching 0, t is approaching cosine of 0, right? And cosine of 0 is 1. If t is approaching, if x is approaching pi all over 2, t is approaching the cosine of pi over 2, which is 0. And up here, cosine squared of x up there is t squared, and then divided by 1 plus cosine squared of x here, which is t squared, multiplied by sine of x dx is equal to negative dt. Now let us recall, when we have the integral from a to b of f of x dx, this is equal to the negative integral from b to a. We switch the limits of f of x dx. So we're going to do that here. Therefore, using that property, our I is going to be equal to the integral then from 0 to 1, right? So up there we have t squared, which I know is same as t squared plus 1, and then minus t squared. Oh, minus 1 I mean. Oh, sorry for that. So minus 1 then divided by t squared plus 1 and then dt. Split the denominator, we get the integral from 0 to 1. So here we're going to have t squared plus 1 divided by t squared plus 1 dt, and then minus the integral from 0 to 1. So we just have 1 over t squared plus 1, and then we have our dt. Okay, so from here now, so we know this get cancelled, we have 1. The integral of 1 with respect to t is giving us t. So I is equal to t with a limit running from 0 to 1, and then minus. So this 1 here is same as 1 squared. Then we use this standard integral formula. The integral of 1 over x squared plus a squared with respect to x is equal to 1 over a multiplied by the inverse tangent of x over a and then plus c. And we can see here our a here is equal to 1. Therefore, we're going to have just the inverse tangent of t, then with our limits from 0 to 1. So here I is equal to here, take the upper limit 1 minus the lower limit 0, then minus here, take the upper limit tangent of 1 minus the lower limit tangent of 0. So from here, we finally get our solution. 1 minus 0 is 1 minus, so the tangent of 1 is pi over 4. Tangent of 0 is 0, and here we have our solution, which is 1 minus pi over 4, which is approximately equal to 0.214. Right? 601, hope I'm not making a mistake, 8366. And here we have our solution. Did you enjoy the video? Kindly support the channel by subscribing. Also like, comment, and share.